Our universe, with its trillions of galaxies, billions of stars, and countless planets, has existed for about 13.8 billion years. According to the most precise observations humanity has ever made, it all began from a state of extreme heat and extreme density, known as the Big Bang. But the Big Bang was not an explosion in space. It was an expansion of space itself. There was no central point from which everything blasted out. There was no empty void outside for the universe to spill into. Space itself, along with time, was born in that very moment. Everything you have ever seen, mountains, oceans, cities, people, was once compressed into a state that our current laws of physics cannot fully describe. But the question that haunts scientists the most is not what happened after the Big Bang. It is, did anything exist before the Big Bang? If the Big Bang was the beginning of time, does the concept of before even have any meaning? Or is our universe merely one phase in a much longer chain that we have yet to observe? When physicists rewind cosmic history using mathematics and astronomical observation, they can describe the universe's earliest moments with astonishing precision. In the first few thousandths of a second, the universe was a state of extreme heat and density, flooding with raw energy. Within just minutes, protons and neutrons forged together to create the nuclei of hydrogen and helium. About 380,000 years after the Big Bang, as the universe finally cooled, electrons were trapped by nuclei, forming the very first atoms. In that moment, light broke free, traveling across space to reach us today. We call this ancient light the cosmic microwave background, the CMB. Hundreds of millions of years later, the first stars ignited. Galaxies took shape. Matter organized itself into the majestic cosmic web that our telescopes observe today. Every modern physical model confirms this. The Big Bang is not a vague guess. It is a conclusion forged by decades of hard empirical data. But as we push closer and closer to that very first moment, the equations begin to destabilize. As we continue to rewind cosmic history to even earlier moments, approximately 10 to the minus 43 seconds after the Big Bang, we hit a limit known as the Planck time, or the Planck epoch. At this exact instant, the universe was so small that it is unmeasurable by any device. The energy density was so high that all existing physical theories lose their validity. The two greatest pillars of modern physics are general relativity, which describes space, time, and gravity; quantum mechanics, which describes the microscopic world. Both of these theories are incredibly accurate within their respective domains. But when we enter the Planck epoch, they are no longer compatible with each other. We do not yet possess a complete theory of quantum gravity, and therefore Current science cannot accurately describe what happened before the Planck time. To be serious and honest, modern science simply does not have the tools to study before the Big Bang. Because if time only began to exist with the Big Bang, then the concept of before that might have no physical meaning. The question, what was before the Big Bang, may be akin to asking, what lies further north of the North Pole? For decades during the 20th century, scientists believed that the universe would not expand forever. They hypothesized that the gravitational pull of all matter in the universe would eventually slow down the expansion, and then reverse it. Galaxies would stop drifting apart. Instead, they would rush back together, colliding and crushing everything until the entire universe collapsed back into a single point. This scenario is known as the Big Crunch. If the Big Crunch were real, the Big Bang might just be one phase in a much larger cycle. Expansion, collapse, and then expansion again. Some physicists call this the cyclic universe. However, since the late 20th century, astronomical observations have completely shattered this picture. In 1998, astronomers made a shocking discovery. The universe is not just expanding, it is accelerating. A mysterious form of energy known as dark energy makes up about 70% of the entire universe. It is this invisible force that is pushing galaxies apart, driving them away from each other faster and faster with every passing second. Data collected over the last 2 decades points to a hard truth. If this trend continues, gravity will never be strong enough to pull the universe back into a big crunch. The classic theory of a collapsing universe has been effectively ruled out. Instead, the leading theory for the end of everything is now the Big Freeze. The universe will expand forever, growing colder, darker, and emptier, until the very last stars finally fade away. Although the classical Big Crunch is no longer strongly supported, some physicists are still trying to preserve the cyclic idea using newer models. One of these attempts comes from theories of quantum gravity. According to these models, when a collapsing universe reaches an extreme, near infinite density, instead of collapsing into an infinite singularity, it could bounce back. This phenomenon is known as the Big Bounce. In this view, the Big Bang may not have been the absolute beginning, but rather the direct result of a previous universe that had collapsed. However, it is crucial to emphasize one thing. To this day, the Big Bounce and the cyclic universe models remain purely theoretical, confined within mathematical frameworks. There is currently no direct observational evidence to confirm that they are true. Nobel Prize-winning physicist Roger Penrose proposed a unique model called conformal cyclic cosmology, CCC. According to his theory, Each cosmic cycle ends with the complete evaporation of all black holes, and that event then becomes the Big Bang of the next cycle. Penrose claims that within the cosmic microwave background, the relic light of the Big Bang, there may exist specific spots, which he calls Hawking points, that are the residual traces of black holes from the previous universe. However, to date, this result has not been independently verified, and the majority of the physics community still views this as a highly controversial hypothesis. It is not yet accepted as conclusive evidence for a preceding universe. Another mystery that fuels speculation about a previous universe is the fine structure constant, alpha, which has a value of approximately 1/137. This single number determines the strength of electromagnetism. If it were even slightly larger or smaller, atoms would not be stable, stars would fail to ignite, and life itself could never exist. Some studies have hypothesized that alpha might actually shift across time or space. If that were true, it would shake the very foundations of modern physics. But, as of right now, there is no robust evidence to confirm that alpha actually varies. After all the models, the hypotheses, and the debates, the scientific truth stands as this. We understand the universe with incredible clarity from just a few millionths of a second after the Big Bang. But we remain completely blind when we approach the moment of origin. And we have absolutely no way to verify what happened before it. A previous universe might have existed, or perhaps there is simply no before in any physical sense. The Big Bang could be the absolute beginning, or it could be just one link in an infinite chain. Science simply does not have the answer.